Here's test number 2 for ECE 463-663 Monitoring Control. This is a take-home test. You'll have all the way until Sunday, March 30th to complete this. It's going to take some time, so don't put it off to the end. The goal is to take a ball and beam system that we've been looking at this semester. The beam has a mass of 0.7 kilogram meter squared. The mass has a mass of 2.2 kilograms. The linearized dynamics from homework set 4 are as follows. What I want to do for this homework set, or the test, is have it follow the following path. This is a triangle wave. That's for a nominal case when the mass is 2.2 kilograms and when the mass is different. Assuming you only measure position and angle. So what that means, think Fourier transform. If this is the desired path, that's not a sine wave, but from Fourier transform, I can express that as an infinite series. If I treat that as just 3 terms on the Fourier series, what essentially I'm trying to do is track 3 different sine waves. One at 0.5 radians per second, one at 1.5, one at 2.5. So in the solution, you'll need to come up with a control law that can track 3 sine waves. If the mass is different than 2.2 kilograms, I'll need to design an observer that can reject a disturbance at those 3 frequencies. So what it should look like when you're done, if you go to Bison Academy, I've got 3 different files. The beam dynamics, and beam display under test number 2. The display is what we had before on homework set number 8. It displays the ball and beam system as well as a full order observer. The dynamics include a mass of 2.2 kilograms. This will change when I want to check for a constant disturbance. And the beam system, this is kind of the starting point. I've got the plant dynamics, the control law. This is the wrong one, but at least stabilizes it. The observer isn't in there currently. You'll have to add that, the observer gains. And currently I'm cheating. The observer just follows the plant, and I'm feeding back the plant states. You'll eventually want to change that to the observer states. What this looks like, when I run it, here's what it looks like initially. I've got the beam, a little motor on the torque, spinning it up and down. The X is your set point. That is just a ramp going left and right. And the ball is the red one. The observer is the green one. I want to have the ball track the set point as it goes back and forth. And you kind of see the starting code. It's stable, but it doesn't track very well. That's the goal on the test number 2. Come up with a control law that will track 3 different sine waves, assuming you can measure all the states. Come up with an observer to estimate the states, assuming you can only measure position and angle. Put the 2 together, I should be able to track that set point going up and down, left and right, using only 2 states, tracking at least the first 3 harmonics. So that's the 2 problems. The first problem is design a control law. More and more points as you add, make it more and more complicated. If you're shooting for an A, I want to track 3 different sine waves. One at 0.5, 1.5, and 2.5 radians per second squared, or radians per second. Part 2 is design the observer, assuming I can only measure position and angle. Design a full order observer to track the plant, and as you add more and more disturbances, it gets more and more complicated, you get more and more points. For full credit, I want to track a disturbance at 0.5, 1.5, and 2.5 radians per second. That would be when the mass is 2.5 kilograms. And in your solution, include a block diagram of your plant controller observer, your MATLAB code, the response to the linear system, response to the nonlinear system, and response to the nonlinear system for the nominal case, as well as when the mass is 2.5 kilograms. So that is test number 2. It's going to take some time, so don't put it off until Sunday night, but you'll have a whole week to work on it.